for the past 6 months, I haven't been using email. Rather, I've been using this AI agent to check email for me. It drafts responses, it schedules meetings. I'm still in the loop. It's still very human in the loop. But the idea is I have this AI agent that's monitoring my email inbox, and it's alerting me when there's things I should see, or when there's drafts of emails that I should approve, or anything like that. So in this video, I want to walk through how to run this yourself, as well as some of the design decisions behind what went into the agent behind it. This is a very developer-centric video. You will be running code, writing code, using the raw APIs themselves. If you want to just see how to use this agent, there's a separate video for that in the links below. But if you're here as a developer wanting to learn how to build an email assistant like this, let's dive in. I'm here in GitHub at the EAIA repository. That stands for Executive AI Assistant. And the first thing I'm going to do is I'm going to fork this because I might be making changes that I want to push back up to a GitHub repo. Let's go ahead and fork this. I'll leave it all the same. And let's create the fork. Now that this has been forked, I'm going to clone it locally. Let's open it up in PyCharm. Great, I've got the README here. Let's now walk through how to set this up and run it. So I already did this. I'm now going to create a virtual environment for this. Awesome. I'm going to activate that virtual environment. And now I'm going to pip install a whole bunch of dependencies. Next step, I'm going to set up some credentials. So I need an OpenAI API key. This will be used to interact with OpenAI's LLMs. I need an Anthropic API key because Claude Sonnet is a great model and I want to interact with that model as well. I need a Langsmith API key. This will be used for tracing, debugging, but also to run the agent server that's running my agents. And then finally, I need Google credentials. So this is used to access my Gmail and my calendar. So these three are just API keys that you can set in your environment. This Google one is a little bit trickier. So let's go to this link. All right, so there's some steps that I need to follow to authorize credentials for a desktop application. Follow those here. We're then going to go back here and we're going to create this secrets repository where I'm going to put some secrets related to Google. After you've done everything in the UI, you should have downloaded the client secret. You're then going to take the JSON that you should have downloaded as part of the previous step and move it into here. So for me, this is what this file looked like. And I need to name this secrets.json. I'm then going to run this command right here. This is going to ask me to log in to my email and authorize it. It's going to ask for access to my calendar and to my Gmail. Great. After this, if I go back, I should see that in secrets, there is now a token.json. This is my OAuth token that I'm going to use. Before going on, make sure that you've exported these API keys to their respective variables. I am not going to do this live on video, but you should make sure that you have done that. The next step is configuration. Later in the video, I'm going to walk through the code and what everything means. For now, I'm just going to configure the agent in a no-code way. So I'm going to go to this YAML file and open it. I'm going to see a bunch of fields in this file. This is where I can configure the agent to give it background information and tell it how to behave. Let's go through the fields. First up is email. I've redacted mine for now, but this is where you'll put the email address that you want to monitor. Next, full name, then the name you like to be called, some background information on yourself, and now we start getting into the preferences of the agent, how it should respond, how it should schedule things. So this can be things like meeting length. Any background preferences or pieces of information is maybe a more apt description. So this is used generically when responding. So if you want it to know who important people are or important addresses are, you can put that here. Time zone, this is mainly used for scheduling events. Rewrite preferences, this is used for rewriting the email. So we'll go into the flow a little bit down the road, but basically what happens is when we draft an email, we then have an explicit step that rewrites it to really focus on matching a tone that you like. And so you can express that here. Then we have instructions for how to triage emails. And so these are emails that we do not want to respond to. This is triage no. Triage notify is emails that we want to be notified about. And then triage email is emails that we want to respond to. And then finally, we have memory equals true. This configures memory. We'll talk about that a lot later on as well. Great, that's the configuration. Next up, we're going to run it locally. So the first thing we're going to do is install the LangGraph CLI. And what this is going to do is this is going to let us run an agent server locally. Next, we're going to run LangGraph dev. And this will spin it up in a local Python instance. We can see that it opens up LangGraph Studio when it's finished. If you haven't used LangGraph Studio before, I'll include some links in the description, but basically this allows us to visualize and interact with our agent. We're not going to dive into the agent right now, but we'll return to this screen later on so we can walk through what the agent looks like. If you want a sneak preview, you can look at it here. Awesome. What's up next? Now we want to ingest some emails locally. So this is going to kick off an ingest job that's going to look at emails and send them through our local email assistant. So what we need to do is we need to open up a new terminal. I'm going to go back into this directory. I'm going to reactivate my virtual environment. And then once I've done that, I'm going to kick off an ingest job. And I'm going to run it for the past, let's say 4 hours. What these flags mean, minutes since is how many minutes to run it. And this will look at all emails that have arrived in these last 240 minutes. Rerun is going to be rerunning for any emails that it has already kind of like seen. And early means it's just going to keep on going even if it sees emails that it has already seen. So this is just doing a full rerun of all emails. Let's kick this off. So we can see that it actually failed on one. I need to look into this to see what's going on. It failed on a few. I'll debug that separately. And if we go over here, we can see that there is a bunch of stuff happening. And this is the agent now kind of like running in the background. We can now set up the agent inbox with this local agent. So let's go to this URL. This is where I can access the agent inbox. And I can now set up a new inbox. So what I can do is I'm going to add the graph ID of main. Main is the main assistant. There's actually a few other graphs. We'll talk about that later on. But I'm going to add that there. I'm then going to add this as the URL because this is where it's running locally. And I'm going to name this EA Dev. Let's submit this. And I can see here that I now have a few emails that require my attention. Now you may be wondering why there's so many actions here that require our attention. Isn't this an agent that we just launched? What's going on? Well, so this is an agent that's really focused on human in the loop. And so I want to be in the loop anytime it does something for a few reasons. One, I don't quite trust it yet. I don't trust it to email autonomously or schedule calendar invites completely on my behalf. It can definitely write drafts, and it can create a plan to schedule something. And you can see in the other video that I'll link to in the description of how to interact with this agent, but I can then just like click accept. And so it's super easy, it speeds it up, but I don't fully trust this. That's reason one. Reason two is this human agent collaboration is great. This back and forth is fantastic because the agent can learn from that and start to develop long-term memory. And so I really do want to interact with it just like I would interact with an EA or a human, so that they can start to get a sense of who I am, what I like, how I want to respond to emails, things like that. So we've just deployed this locally, and that's great, but my email's not always running, it's not always on, and so I want to deploy this in a more production-ready way. And so in order to do that, I'm going to deploy it on LangGraph Cloud. So what I'm going to do is I'm going to go to Langsmith. I'm going to go to LangGraph Platform here, and I'm going to click New Deployment. It's connected to my GitHub, and I'm going to select the repo that we just created. I'm going to name it EA for video. I'm going to point it to the main branch. I'm going to point it to this langgraph.json. We'll talk about that in a second when we talk and walk through the code. Development is fine. I'm going to add in a bunch of environment variables. And so I'm not going to do that, but these are the OpenAI key, the Anthropic key. I don't need to add my LangChain or LangSmith key because that will be automatically loaded for me. And then I need to load these two extra ones. So I've got these two files here. These are basically my Gmail secret and the OAuth token. And what I want to do is I want to take the values of these and add these as environment variables to the deployment. So I'm not going to do that live, but basically you can do that by adding them here. And then you can click submit, and it will go ahead and deploy it. After you've deployed it, it should look something like this. You probably won't have this traffic. I've had this deployed for a little bit now. If we go back here, the next thing in the step is to kick off an ingest manually. This will kick off a manual ingest job. I'm not going to do that because I've done something that we'll talk about later on how I can set up a cron job already. But you can run this if you want. This will do the same thing as it did locally. We then want to connect this deployed agent with our agent inbox. So I can go back to the agent inbox here, and here we had this dev. We can see here that I've now connected it to the production deployment. And so the way to do that is you go in settings. You should make sure you have your API key here. You didn't need this when you were running it locally. You do need it now. You click add an inbox. You use main again as the URL. And then you come in here, you take your API URL here, copy that. You can put that here and then give it another name, and it will show up here. So you can add your deployed agent to your inbox in this way. Then the last thing that we're going to cover is setting up a cron job. So you don't want to run this manual ingest all the time. That's really annoying. You want it running in the background. So you can do that by running this command here. So you're going to take that URL, which we just found, and then run this Python command right here. That'll set up a cron job. That cron job will run every 10 minutes, and it will check your inbox for new emails and then deal with them accordingly. All right, so we set up the email assistant. We've got it running. Let's now walk through the code and explain in a little bit more detail what exactly is going on. So to start, let's take a look at the langgraph.json. This is where we define our agents. We can see that there's actually a few things in here. So in graphs, there's actually 4 graphs. The primary one that we're going to care about is main, but we'll talk about these other ones as well. We can see that in addition to the graphs, there's also the store configuration. This configures support for semantic search within our long-term memory store. So if you're using memory, there are some cases where we're going to be doing semantic search over contents of that. And we'll talk about where those are later on, but this configures how those are run. So I'm using OpenAI's text embedding 3 small model. At the top level, there's not too much else. We've got this scripts directory, and we'll talk through what's in there. We've already used some of these. We've got this EAIA directory, and we'll talk through that in detail. And then there's the only other thing that's maybe worth looking at is pyproject.toml. This just lays out all the dependencies that we need. So you can see that we have LangGraph, we've got the checkpointing library within LangGraph, we've got some LangChain, OpenAI, Anthropic packages, we've got a bunch of Google stuff for interacting with Gmail, and then some other stuff which is useful for dates. The dependencies are pretty light, so let's jump into the code. Let's first look in EAIA. There's a few things within here. There's this main directory. This contains all the logic for the main graph, and there's a bunch in here, and so we'll walk through this. There's two other files that are related to graphs. This is cron graph, and this is reflectiongraphs.py. And so if you remember in langgraph.json, we had these other graphs here. Those are going to be in these other Python files. We'll talk about those at the end. Before we jump in to the main agent, let's look very quickly at schemas.py. So this contains a bunch of schemas related to the state of our agent or agents, as well as some typed dicts or some pydantic models that we're going to use to structure the agent's output in various points. We've also got this gmail.py. If we click in here, there are a lot of helper functions related to parsing emails, sending emails, parsing parts of emails. And so there's a lot of helper functions in here for basically just dealing with Gmail and calendars. Some of these are helper functions, some of these are tools. All right, let's take a look at the main agent. There's a bunch of files in here, and if we click into graph.py and scroll to the bottom, this is where the graph is compiled and built. As you might notice, there are a lot of nodes and a lot of edges. Rather than walk through these in code, I'm going to use LangGraph Studio to get a visual representation of what's going on. Then I'll return here and talk through the specific Python files and how they match up. So I'm going to go over here. If I click LangGraph Studio, I can see here a visualization of the agent. So start is the place where we start. The email comes in and it hits this node and it goes right away to triage input. So here we're triaging the email that we are dealing with. One thing it can do is it can go to this mark as read node. This will basically mark the email as read and then finish. So it's pretty straightforward. Another relatively simple thing it can do is it can go to notify. So triage input is using an LLM, and that's how it's determining how to go. And if it determines that an email is worth notifying us for, then from there it will go to human node. The way to think about human node is this basically matches up with the agent inbox with which we saw. So you can see here that I have a notify. So from here, it interrupts the graph, and we'll talk through how it does that, but it interrupts the graph, it sends something to agent inbox, and it waits for our response. The third thing that this triage input node can do is it can send to this draft response node. This is the main email agent that has access to more tools and tries to write emails. And so let's walk through that. We can see that there are a lot of branches from here. One, it could decide to send a message. Sending a message is not sending a message to the recipient, but rather sending a message to me, the user. And so if we go back here, we can see that we have some questions. This is where the agent decided here that it wanted to ask me a question about how to respond. Another place that this can go is over here to find meeting time. So we'll talk about this in more detail, but find meeting time is actually a sub-agent that has some tools. And so this will find a meeting time. From here, it can also send a calendar invite. So the way that it basically works is this main agent can call the sub-agent, it finds a meeting time, then it goes back to this main agent, and this main agent can send a calendar invite. Another path that it has is this rewrite thing. So you can see here that there's this sequence, rewrite and then send email draft. So basically what's going on is I have an explicit rewrite step for all emails that I want to write, because I do not trust, I've done some prompt engineering, and basically if this tries to think about what to do and think about the tone to write the email in, it doesn't produce good results. So this just drafts a draft, and then there's an explicit rewrite step. And then this, as it continues, will go to the step where it tries to send the email. There are a few more places that go into the human node. Send message, it goes to the human node because it goes to agent inbox. email draft goes to the human node because it wants me to approve it. Send calendar invite, it goes to the human node because it wants me to approve it. The last thing that this main agent can do is it can basically go to this tool node, which is used for when it has a bad tool name, when the agent has hallucinated a tool to use. This can happen because the instructions that it has are pretty complex, and so it might mess up. So it goes here, and then it will come back in with some self-healing. From the human node, so after the agent inbox, you can see that there are a few paths it can go on. So one, it can mark it as red. So when I press ignore in the agent inbox, what's happening is it's going back into the graph. It's picking up from here, and it's going to this mark as red node. It can also actually send the calendar. So, send cal invite. This is just drafting an invitation, a calendar invitation to send. This is where it actually happens. After it actually sends the calendar invite, it then goes back to the main agent. And so it can continue and usually say something like, hey, I just sent a calendar invite, something like that. Send email node will then go to the mark as red node, and then it will finish. So the sending of the email is the last thing that this agent generally does. And so one improvement, if you wanted, would be the ability to have it send an email and then go back to this main agent and then send a calendar or send another email or something like that. But at the moment, that's not supported. So that walks through what this agent does at a high level. Hopefully that's helpful. Now let's walk through the code to see how exactly it's done. So this is where the agent is defined. There's not a ton of logic in here. There's some basic routing logic. So this takes in the triage step and goes on to other things, but there's not a ton in here. It's basically a bunch of conditional edges in dealing with bad tool names, and that's basically it. Conditional edges are defined in this file. Let's kind of go through it in order. So let's go to the triage node first. So this is the agent responsible for triaging. If we scroll down here, we can see that there's this really complicated prompt, which we're formatting with a bunch of information. We're getting some few shot examples. So I'll talk about this when memory happens a little bit later on, but basically we're getting this prompt, we're getting some few shot examples. We're using OpenAI here, and then we are doing structured output generation. And so we're using this respond to schema. If we go here, we can see here that the LLM is generating logic and then response. And so the response types can be no, email, notify, or question. Question is something that's not handled. So this is a legacy thing that I actually experimented a little bit with, but basically didn't see a ton of use in. The reason being, it's pretty similar to notify. So no is like ignore it, email is send an email, and then notify is notify Harrison. Question was supposed to be like if the agent didn't know what to do, it could generate a question and send it to Harrison as well. That's very similar to notify, and so I saw in practice that the agent would always just kind of like notify me, and so this isn't really used. That's pretty much it. The only other interesting thing to maybe call out here is this delete messages step. So as I mentioned, the triage input is the first thing that happens. Now, the way that I handle email threads is that it actually continues on the same thread as before. But what I want to do is I want to wipe any previous conversation that I had with the agent before continuing with a follow-up email. Now, you can argue whether this is the right thing to do or not. I think in practice, what I would want is actually to create a summary of the conversation that I had with the email agent, and then save that. But right now, I'm basically just clearing all the messages that come in. So I'm adding the remove message signals to the state update, and then I'm updating the triage part of the state with the response. Okay, so that's the triage step. After that, I'm not going to talk about notify because I'm going to talk about that in the agent inbox. So let's go into this main draft response pie. So this is the main agent part right here, where it can loop and do a bunch of stuff. And so we can see that there are some pretty complex instructions here saying when to use tools. We initialize a model. We turn off parallel tool calling. So I don't want this to call multiple tools at a time. I just want it to call one. This was mainly just to make the code easier. I give it access to a bunch of tools. So it has the ability to draft new emails, respond to emails, send me a question, ask the meeting assistant when I'm free, and send a calendar invite. And then if there are any messages in it, I also give it the ability to ignore the email. So the reason I do this is that the first time it enters this, there won't be any messages. And I don't want it to ignore the email because I previously just had a whole step that decided that this was an email worth responding to. But if what happens is this sends a message to me and I say in the human node, like, hey, this isn't really worth like responding to, just ignore it. I want this main thing to be able to ignore it and not proceed. And so basically what will happen is if there are these messages, the messages represent back and forth between kind of like me and the agent, then it will append this tool called ignore, which it can call to ignore the email. We can see here that I'm loading a bunch of stuff from store. So store is long-term memory, and this will basically be used to fetch long-term memory. And so I'm loading it from there, and then there's some stuff. This is basically checking if it exists in the store. If it doesn't exist in the store, then it's putting it in the store so it can update and fetch from it later on. It's constructing this prompt. It's constructing a message from this prompt. And then it is calling it's binding the tools to the LLM. It's calling the LLM with these messages. And then I have this little loop here where basically if it doesn't call a tool, so remember, when I configured the model, I told it that it can't call parallel tools, but I also said tool choice equals to required. So it has to call a tool. And if for whatever reason it doesn't call a tool, sometimes I saw that it messed up. Or it called multiple despite prompting, or despite the configuration, the prompting wasn't good enough, I guess. And so if that happens, then I just go in this little loop, and then I update the response, the state with the response message. Okay. So what do these tools actually do, and where are they defined? So new email draft, this is defined in gmail.py. This is sending a new email. This is responding to an email, also in gmail.py. Sending a calendar invite, also in gmail.py. Asking a question, this is in the human inbox stuff. And actually, so when this new email, for all these things, there's still a human in the loop approving it. And so all of them actually go through the human inbox. And so this is a really important file, and we'll go to that in a little bit. But first I want to talk through Meeting Assistant, because this is actually a sub-agent. And so this is in findmeetingtime.py. We can see here that I have a complicated prompt. So this is actually the only agent that has access to the calendar. And so if we look down here, we can see that I have this node defined here. I load a model, and then I create a React agent. So this sub-agent is actually a much simpler architecture of agent. It's just a React style agent and only has one tool, get events for days. If I go to this is defined in gmail.py. This is a tool that basically interacts with the calendar itself. So the main agent doesn't have access to this tool. It can just call this sub-agent, which has access to this tool, to do its work for it. And I then create kind of like this input message and invoke the React agent with this message. Now, the response that the React agent sends back is actually going to be a list of messages, because it's going to do some tool calls. It's going to build up state of kind of like AI message tool call, and then it's going to finish with an AI message. And so I'm getting the last message in that list of messages. And then what I'm returning, and remember, this will be returned to the main agent. So the main agent generated something like call this meeting assistant agent. What it needs to get back, a tool message. So this agent is doing a bunch of work. None of this is going to show up to the main agent. What it's going to see is it's just going to see the response from the sub-agent as a tool message itself. So there's other prompting strategies you could do here. That gets into some like multi-agent communication and what's the best way to do this. We have some other work on that will be coming out. But for now, the way that I did it is I basically just constructed this tool message, which the main agent needs to see as a response. It needs to get this tool message as a response. And the content of this tool message is the response from the sub-agent. So that's kind of what's going on here. So the other thing that I want to talk about before the human inbox is rewrite. So this is just rewriting the draft of an email. And so we can see here that I have this rewrite prompt. I load this model. And then basically what I'm doing is I'm getting the previous tool call. So the main agent called this tool to draft an email. And as part of that, it did have the content of the email. And so I'm getting that. So this is tool calls, gets the first tool call, gets the content arg. It gets this as a draft. And I'm passing that in to the agent to rewrite the email. Now, what is it getting back? I'm doing with structured output, so it's getting back this rewrite email, which has logic. So logic for the tone of the email, and then it has the rewritten content. So it has the rewritten content itself. Okay, so what is it doing with that? We can see here that it's updating the state with a message. But what is this message? Notice that it has the same ID as the previous message that we got from the main agent. So the main agent generated this tool call. The tool call is a draft of an email. That tool call has an ID. We are then adding a new message to this list, which has the same ID. And what will happen is in the state, because they have the same ID, the most recent one will overwrite the old one. So this one's going to overwrite the previous tool call. And then what's going to be in there is the new content that we generated from the response. So here we can see that we have this list of tool calls. This list of tool calls is the only thing that's not new, right? So previous message ID, same. Content, same. Tool calls, different. In the tool calls, what's different? The ID is the same. The name's the same. All the args except for the content are the same. The content is different. The content is now this rewritten content. So basically what we're doing is we're having the main agent generate a tool call that corresponds to a draft of an email. We're then having another agent take that tool call and update the content field in it. So we're basically just updating a tool call. All right, so now let's check out the human inbox. And this is where a lot of the human in the loop interaction pattern happens. So we can see here that we have some schemas defined. These are the schemas of how the agent communicates to the agent inbox. And these are actually now in the LangGraph package themselves, so I could import them from here. This is an older project before that even existed, so I had to find them here. We now have this template. So this is what shows up as details on the right-hand side when you open an email in the agent inbox. So when you open an email in the agent inbox, you have the actions you can take on the left and some content on the right. This is the template in Markdown that defines that content. So we can see that we put the subject of the email at the top. We then add this place to click here to view the email. And then we put the information of the email itself. So who it's to, who it's from, and the content of the email. After that, we have a few helper functions that aren't too important, but then we get into the important things. And these are nodes. So all of these are nodes in the overall graph. So this is the send message node. Now remember, send message is when it sends me, the user, a message, not an email. It sends me a question. So what is it doing? Okay, so we can see that it's getting the tool calls and it's getting the most recent run. And we know that this will be the question tool call. Now it's creating this human interrupt thing. And it's basically saying, this is tool call name, this will be question. It's putting through, so action request is basically what action we're looking to take. So it's putting that here. And this is the tool call of question, and the arguments are the inputs. I now have this config. This is saying the human's allowed to ignore this. It's allowed to respond to this. It can't edit it because there's nothing, this isn't an action that I'm going to take. This is an action for communicating with the user. So there's nothing to edit and there's nothing to accept either. And then this is the description that shows up on the right. So it generates this request. This is still a Python dictionary. It then does this. Interrupt, passes in the request, and gets back a response. What's going on here? So interrupt is something we added in LangGraph. This is basically the most up-to-date way we have to do human in the loop. You can think of this as basically similar to the input function in Python. So if you were just running this in the command line, you could use input. And it would do something like that. It would print this out to the command line. You could type back in, and then the response of what you type back in would be this response. That's basically what's going on here. We're interrupting. We're sending a list of things. We're getting back a list of things. We know that there's only one thing in the list, so we're just going to get the first thing. And then this is the response that we get back from the user. So what is the response? Well, the response is some schema, and there's a few types that this response can be, and the type is represented as a key in the object that we get back. So we can see here that if we get back a response type of ignore, what we're going to do, that's signaling to us, that's signaling to the agent that we want to ignore this thread that's going on. And so we're going to add a new message to the list of messages, and we're going to simulate that message is calling the tool called ignore. And we'll see later on what comes after this and how we deal with that. But that's basically saying, okay, we're going to add this new message that's mocking, that's simulating as if we actually ignored the response. The other type that it could be is a response. So this is the response where I answer questions. So it could ask me like, do you want to go to this event? And I would type back in yes. So what happens if I type that in? Well, what happens is we are going to create this message. And this message is the thing that gets added to the state. So we're creating this message. And in that message, it's going to be a tool call response. And the content is going to be the response content that I responded. So the way that the main agent will see this is it will see a list of messages. One is the main agent, an AI message that calls a tool called question with the content being the question that it's asking. And it will get back a tool response, and that tool response is what I type back in. Now, the other thing you'll notice here is all of this fun logic. So this is under the if memory branch. So as I mentioned, memory is configurable. If you choose to have on memory, it will go down this path. What's going on? It's first calling the save email function. What does this do? Let's check it out. Okay, great. So what it's doing is it's basically adding few shot examples of emails and how they should be triaged. So here you can see that we get the namespace for working with our long-term memory store. So that's this. This is the long-term memory store. We then look to see if this email is already in the store, because there's just back and forth, and this could actually be called several times. Only the first time that we hit this do we want to do anything. So we look to see if this is already in the store. If it's not in the store, then we're going to add it to the store. And so what we're going to do is we're going to add this data, and it's going to have as input the email content. So this is the content, who it's from, who it's to, the subject, things like that. We're going to add that, and then we're also going to add in the status that we want it to be. So this will be a few shot example in the future. And so remember how in the triage step I said that we were calling this function called get few shot examples. If we go here, we can see that what this does is this actually searches the store for the same namespace where we are saving it in the agent inbox. Great. So it's going to be fetching those, and it will be inserting those. So here, so this save email thing that we call, this is saving it as a few shot example. And we do this whether it's ignored or whether we get a response back. Now, if we get a response back, we have a lot of information we can work with. We can use that response to maybe update some of our other instructions or some of our other background information. And so what we do is we create this new state, and we pass this to a reflection graph. And I'm going to talk about that at the end. But basically, we trigger this reflection graph with this response we get back. Okay, now remember, this is just what happens when I respond to a question from the agent. There's other things I can do. So let's take a look at this. This is when the agent sends me a draft of an email to approve. Similar things going on. I create this action request, which is basically the actions and the arguments. And now in the config, I'm allowed to ignore it. I'm allowed to respond to it. I can also edit it, and I can also accept it. Okay, so now what happens in all those things? If I respond to it, we see a similar thing. We create a message, but now look at the content. So here I say error, user interrupted and gave this feedback. So remember, what the agent has seen or what it has in its message list up to this point is it has an AI message where it generates a tool call for an email draft. Then what's going to happen is it's going to see the next message is a tool call message, and the content is going to be error, the user interrupted and gave this feedback. So the idea is that the agent should think that it tried to send an email and that the user interrupted it and gave it some feedback. That's exactly what happened. And so that's how it's going to be represented. It's going to be represented as this AI message and then this tool message. The tool message's content is going to contain the error. There's other ways you could represent this. You could have an AI message. Then you could have another tool call message that says like sent to user. And then you could have a human message which contains the feedback. This is just prompting strategies. You could do either. We can see here that we have memory again. Ignore is similar as before. Now we get into what happens if you edit an email. what happens is we basically take the previous message that the AI generated. So here we can see we're working with an AI message. It has the same content as before. It has the same ID as before. Has similar tool calls as before, except the arguments are different. The arguments are the ones that we edited. And what's basically going to happen is we're going to update the state with this message because it has the same ID as the message that's in there before. It's going to overwrite it. And we'll see how this is handled in the conditional node after the human inbox. We can see here that we have similar memory. We save it as a few-shot example. We also pass this in to an agent to reflect on what the edits were made. And then if it's of accept, great. We don't really do anything. We save the email, and this saves it as a few-shot example, but we don't do any more reflection because there's no real feedback from the user to update things on. And we do not update the state with any messages. We just return directly. All right, notify. Notify, this is when it just notifies me of something interesting. Similar thing for notify, you're allowed to ignore it. You're allowed to respond to it as well. You're not allowed to edit it or accept it. There's nothing to edit or accept. We get the response back. If we get a response from a user, so if type is response, then we're going to add a message, which is a human message. So what the AI agent will see is it will basically see an AI message where decide to notify. As part of that also, we added in some message that was like notified the user, and then it will see this user message with whatever I typed in. So that's kind of how we're doing the prompt engineering there. And because there is some response, we trigger some long-term memory. If it ignores it, we do a similar thing as before. We just simulate as if there was a ignore tool call at the end. And finally, send calendar invite. This is very, very similar to the email. We're allowed to ignore it. We're allowed to respond to it. We are also allowed to edit it and accept it. This is a calendar invite, so there are some parameters that we can edit and accept. And then similar thing, for if we get a response, we basically use this as the tool call response and simulate an error. If we ignore it, we simulate an ignore tool message. If there's edits, then we update the previous message and we call long-term memory. And if it accepts, then same thing. Not a ton to update on the memory side and no messages to update. So I spent a lot of time on this file, probably the most on this file, but that's because the biggest thing about this agent is the fact that it's very human in the loop and that it communicates to us. It asks us questions. We approve things. And so this is actually where a lot of the complex logic lives. And actually, most of the complex logic is hidden inside LangGraph and LangGraph platform. Because a lot of the complex logic is how do you stop at a particular point in time? You then get some update from the user, but then you need the exact point in time where you were before to resume from there and to continue. You need the state and you need the position in the graph. Speaking of the position in the graph, real quickly, let's check out the conditional edge that happens after. So this is enter after human. Let's see what's going on. We can basically see that if there are no messages, this is what happens if the triage was marked as notify and there's no messages because it never got to the thing that generates messages, which is the drafting email agent. It was this triage step is notify, there's no messages. Great. If we get here, that means the user also didn't change it. So great, notifies, great. Let's mark this as red and continue. Okay, now if there are messages, what do? First, we check if the last message is a tool message or a human message. So this basically happens when the user gives feedback, specifically feedback in the form of responding to the assistant or telling it to do something, not editing something. We'll see what happens to that later on. If it has a tool message or a human message, then it goes to the draft response node. This is the main agent that does everything. So basically for the cases where the human responds or the human says like, no, this is the wrong tone of the email, make it XYZ, it'll go back to the agent. Now, if the last message is neither of these, that means it's an AI message with some tool calls. And these are tool calls that are either A, the ones that the agent generated, B, the ones that the user edited. So it could be like the updated tool call with the updated content of the email that the user generated, or C, ones that we added based on what the user said. So ignore here, this is, if it gets here, this is always cases where I press ignore in the UI because remember, we add in that fake AI message with a tool call of ignore. And so now here is where we actually execute these tool calls. So this node's responsible for executing this tool call, same here, all the way down. All right, so this covers everything in the main agent. As I mentioned, that's only one of a few agents. Let's check out some other agents. Let's check out cron graph first. This is very simple. This is just the cron that basically loops through emails and triggers the other agent. So we can see that it fetches emails, it loops through them. There's some logic here for basically checking to see if this is an email that we already looked at. And then if it reaches the end, what it does is it basically creates a run with the main agent, passes in some input. Okay, so this is a pretty simple one. The more complex one is the reflection graphs. So this is still pretty experimental. I only added this in the past week or two. So to be honest, this probably is the part of everything that doesn't work the best, but we'll still play around with it and have some fun. Okay, so there are 4 types of instructions that we are updating as the agent. The tone of the email. If I tell the agent to respond in a specific way, or if I edit an email, hopefully we should update the instructions, the memory of the tone that I like. Response instructions, these are like what content to include in the email, or when to respond versus send a calendar invite or things like that. Scheduling is all about how to schedule things, and then background instructions is basically just random information that might be useful in the future. So this is the most kind of like general form of memory. This would be things like in practice. This has picked up things like who people are, what LangChain or LangGraph is, what roles people are at the company, what their emails are, things like that. This is pretty general. These others are very specific to the tone of the email, what the content of the email, and scheduling and how that gets done. Okay, so how are we doing reflection? As I mentioned, this is the part that doesn't work the best. So all of this is absolutely just a first step. I'm not claiming this is the best way to do it, but what am I doing? I have this general reflection prompt. In here, I can see that there's a few things. The prompt is basically you're helping an AI agent improve. You can do this by changing their system prompt. This is their current prompt. So I'm passing in their current instructions. Here was the agent's trajectory. So if you remember, in the human inbox, when I called into this reflection graph, I created this state. As part of this state, I had a list of messages. This messages is basically what we are saying is the trajectory of the agent. Now, the trajectory of the agent isn't just a list of messages. It's more complex than that. However, for a combination of simplicity and generalizability, I've made it so that the trajectory, by the time it reaches this reflection graph, is always a list of messages. So this is where coercion from the overall state of the agent, which is much more than just a list of messages, this is where I make it just a list of messages. That's what the trajectory will be. It will be a list of messages, and this list of messages will usually be something like, here's an email. So the trajectory contains the content of the email, and then any back and forth I have. There are some exceptions to this, I think, where I make up some additional messages to put in. Here's one example. In the rewriting trajectory, so when the rewriting step happens, I actually pass in, I don't include the list of messages itself, I include some different kind of like representation. But the high level bit is I translate the state of the agent at some point into a list of messages for the sake of making it more general, and I pass that into this general reflection step. In addition, I also pass in the user's feedback. So I have the trajectory of the agent, I have the user's feedback, which is usually like things that I answer as questions, or things that I tell it to do differently. And then I have instructions for updating the prompt. These are what's above. So these are all instructions for updating the prompt. And that's because different prompts require different instructions for how to update. When I update the tone, I only want to update the tone. When I update the response instructions, I don't want to update the tone. So I have to give some instructions for how it should improve the prompt. Based on this, return an updated prompt. I should return the full prompt. So if there's anything from that you want to include, make sure to do that. Otherwise, override or change anything that seems irrelevant. I don't need to update the prompt either. So I don't always have to be doing that. And then basically, so in here, this is where the updating happens. We can see that I have this update general thing. I'm using O1. I've found that this is the only model that can reliably do this type of like meta prompting updating of memories. Claude Sonnet is okay, but it errors sometimes. It gets overwhelmed. 4.0 is trash. You should never use 4.0 for updating instructions. It's not good at that. And then basically I call this with this schema. Schema is basically logic, the updated prompt, or update prompt, which is a Boolean of whether to update the prompt. And then if this is true, it should have new prompt, which is a string. But this isn't the only graph in here. I can see that I have, so this is the general reflection graph, but I can see that I also have a multi-reflection graph at the end. Now what's happening here? Basically what's going on is kind of similar. We're creating kind of like a trajectory of messages, but then we are asking a model to choose which types of memories to update. So if we look at the prompt here, we can see that it has this format. You're helping an AI agent improve. You can do this by changing prompts. Here was the agent's trajectory. This is same as the step above. Here was the user's feedback. This is same as the step above. However, instead of asking it to update a specific prompt, we're saying these are the types of prompts that you can update. Please choose the ones that are worth updating. And so here, we have instructions for when to choose to update the tone prompt, when to choose to update the background prompt, stuff like that. So to recap everything, what's basically happening is we have this multi-reflection graph, which is triggered in the human inbox. We can see that we're calling multi-reflection graph. It goes in here. It then tries to determine which of the 4 types of memories to update. It'll generate 0 to 4 of those memories to update. And then for each of those, it's calling this kind of like general reflection prompt, which updates these instructions that are found for that user for that type of memory. So again, this is one of the newer things. It doesn't work perfectly, but I have found that this is already a huge improvement into how I use the agent. I don't have to tell it things multiple times. It gets a sense of the tone that I like. So I've generally found that the emails it's drafted are much better. And I think this is probably going to be one of the biggest unlocks in terms of letting people get started quickly with this. So if you remember at the start, we had to fill out this config.yaml. You can see here from mine, there's a lot of instructions in here. And I updated this manually over like the past 6 months. Like it's been a running list. It would be great if I didn't have to do that. And this was automatically generated just by me responding to it. So for example, like when I onboard in a human executive assistant, they have some kind of like instructions for how I want to respond to emails. But then when they're not sure, they ask me. I tell them. And then they probably don't update those instructions, but they at least remember. Or maybe they write it down. Maybe they do actually update the instructions. So I don't have kind of like a picture perfect SOP for the human EA. That's built on the fly through interacting with them. And that's exactly what memory allows us to do. And so that's why even though this isn't perfect and this messes up, and there's some changes I want to make as well. Like I want to change, I have this background instructions right here. I looked at this the other day. My background instructions are now like this long. It's super long because I have all these information about who people are and things that they like. But that's too much information to include. I want to update this to be a list of facts that we retrieve semantically at runtime. Maybe even some sort of knowledge graph, although that's probably overkill. I don't know. I need to play around with it. So the point is, even though there's a lot to do here, and this is just a start, I'm really, really excited about memory. And memory stems from human agent interaction. Like you cannot have this type of updating if you don't have the agent inbox to give feedback and respond to questions for this agent that we built. So memory and human in the loop are super, super connected. And one of the nice things about LangGraph is we have built-in stuff for memory and built-in stuff for human in the loop. It's perfect. Very little infrastructure work to set it all up. I feel like that's a pretty good way to end it. I just got really excited about human in the loop in memory, and I am, and so I don't really know where I can take the video from here. Hopefully this was a good walkthrough of how to set up and run the email assistant, but then also how we thought about building the email assistant and things that we paid special attention to and all of that stuff. Thanks for watching, and if you have any questions or you want to contribute to it, it's open source, so please do so.